Okay, so we have f of f inverse of x is equal to x. Take the derivative on both sides and you get f prime of f inverse of x times f inverse prime of x is equal to 1. So then f inverse prime of x is equal to 1 over f prime f inverse of x. Okay, so remember this formula or remember how to derive it. The second one's better, but both are okay. So now let's do a few examples in your breakout rooms. And remember, in your breakout rooms, it would be super great if you could keep your camera on and try and speak occasionally, because otherwise there's basically no point in being in a breakout room. So also, here are the course notes for today. Let me give them to you. In the chat, in case you can't get to my website. There you go. So first, I want you to try the following problems. So find the derivative of ln x. And of course, you probably know what the derivative is, but I want you to prove it using the derivative of e to the x. So that's good. To find d dx of sine inverse x. And finally, I want you to find the derivative of f of x equals x plus 2 over x in two ways. First, I want you to find the derivative or find the inverse function and take its derivative. And then using that formula for the second way, use what we derived before. Okay, so use the formula for the inverse derivative and just take the derivative explicitly. Okay, so let me put you in your breakout rooms. All right, it looks like just about everyone is back. So let's start going over these. So for the first problem, we want to find the derivative of ln x. And of course, we know because we have a formula for this that it's just 1 over x. But I don't want you to just use the formula. Otherwise, this problem has no content. What I want you to do is I want you to find this derivative using the fact that f inverse prime is equal to 1 over f prime of f inverse of x. So how do we do this? F of x is just e to the x if f inverse is ln x. And so what does the formula give us? The formula gives us that we do 1 over derivative of e to the x, which is e to the x. And then I'm going to use this symbol to mean function composition. So function composition means if I compose with a function g of x, that means that you get 1 over e to the g of x for some function, okay? So in this case, we're composing with the function f inverse of x, which is what our formula gives us, right? Because we're plugging f inverse of x in for x. And so then we get 1 over e to the ln x, which is just 1 over x, okay? So that's how you do this problem. Could I get some F's in the chat if you're happy? And could I get some questions if you're not happy? Or you can, if you're embarrassed, you can private message me your question, though you have nothing to be embarrassed about. Okay, so I only have 4 f's. Okay, great. Yeah, exactly. So you are. Okay, so great. I have many questions. This is good. So if you're confused, you're not alone. So the first question that I have is, I'm just confused because I thought we're finding the derivative. So we are finding the derivative. We're finding the derivative of ln x, right? And so to find the derivative of ln x, we have this formula. So ln x is equal to f inverse of x, right? Where f of x is equal to e to the x. And so then we're using the formula that we have in terms of f and f inverse in order to get the derivative of f inverse. Does that make sense? Person who asked that question? Okay. So I didn't exactly work backwards, but yeah, so I was just using that formula that I derived. So could we take the, yeah.
Where 1 over e of x?
So the reason we did this is because the formula gives us 1 over f inverse, f prime f inverse of x. So you take the derivative of the outer function f prime, and then you just plug in f inverse of x. So the outer function f was just e to the x, and the inner function was f inverse. So we plugged in f inverse into derivative of e to the x, and that just gives us e to the x with ln x plugged in, which is x. And then we just put all of that in the denominator, and that gives you the inverse. Okay. So why do I have to do the, yeah, okay. So could we just take the derivative as e to the ln x? No, you can't do that. That's not what the formula gives you, but yeah, okay, so let's go on to the next question. So the next question says, we want you to find the derivative of sine inverse of x, okay? So again, we're just using the same formula. The point of these problems was to give you some practice with the formula and how to derive it. So, okay, the first thing we have to do is we know that, so if this is f inverse of x, then f of x is equal to sine x. So what's the derivative of sine x? The derivative of sine x is just cosine x. And then we're composing with the function sine inverse of x, okay? So this gives you 1 over cosine of sine inverse of x. Can we rewrite ln x? Oh, can we rewrite ln x as e? Where did that go? Oh, we can rewrite ln x as e to the ln. Okay, yes, you can do that. Yeah, okay, fine. I guess that's reasonable. Yeah, sure. Okay, so then going back to this, if we're taking, we want to evaluate this expression. And so we're trying to consider a triangle where this angle is theta and sine of theta is equal to x, right? Because that's what sine inverse means, okay? It's the theta such that sine of theta is equal to x. And so any triangle will do, because with these right triangles, only the ratios matter. It doesn't matter the exact numbers. And so if this edge is x, then if if sine theta is equal to x, then that means sine theta is just opposite over hypotenuse. And so then that means the hypotenuse has to be 1. And so then this side, by the Pythagorean theorem, is just 1 minus x squared square root. And so this is cool because it means that sine inverse of x is equal to theta. And so cosine of theta, 1 over cosine of theta, well, now we can calculate cosine of theta. It's just adjacent over hypotenuse. And so then we get 1 over root 1 minus x squared. Okay, so are people happy with this? F's in the chat if you're happy, questions if you're unhappy. Oh, so the second method, oh, for the first problem? Only for the third problem here, okay? All right. So I don't see any more questions, but I don't see an abundance of F's, so I'm a little concerned. Okay. All right. Let's do the third problem then, if I'm not getting any questions. And if you're still confused, you can stay after class and I'll answer any lingering questions. Okay, so for the third one, we have this function f of x is x plus 2 over x, and we want to find the derivative of its inverse. So what do we do? I'll come back. Okay, so first we have to find the inverse. Remember, in order to find the inverse, we replace f of x with x, and we replace x with y. So we get y plus 2 over y. And then we get xy is equal to y plus 2, and xy minus y is equal to 2, and y times x minus 1 is equal to 2, and y is equal to 2 over x minus 1. Okay, so this is good news. This is the inverse of this function. So let's take its derivative with respect to x. So d dx of f inverse of x is equal to, okay, so this is just basically chain rule or u substitution, however, or chain rule, where, so first you take the derivative with respect to 2 over something. So that just gives you 2 over something squared. And then you take the derivative, sorry, minus 2. And then you take the derivative of that something, and that's just 1. So then this is your derivative, okay? So this is the first method that I wanted you to use. The second method involves the formula. So the formula goes like this. Again, we're just doing 1 over f prime f inverse of x. So in this case, f prime is x plus 2. Okay, we have to use the, first we're going to find f prime. So we're going to use the quotient rule. So it's low d high, so x times d high is 1 minus high d low, so that's x plus 2, d low is just 1, and then we divide out by x squared, okay? And so then, now that we can simplify a little bit. We get x minus 2 over x squared, and that's minus 2 over x squared. And so now we're just going to plug in 2 over x minus 1, and we get minus 2 over x minus 1 squared, and that gives you minus x minus 1 squared over 2. And then you, of course, have to take 1 over this. So that gives you 1 over minus x minus 1 squared over 2, which is equal to minus 2 over x minus 1 squared. And the point here is that this matches this. So you see that the formula works. Okay, so are people happy with this? Okay, that seems like a good number of f's. And if you have questions, please ask. So, all right, we still have time. So now I'm going to talk a little bit about the next topic in your course, which is extremely useful. It's L'Hopital's rule. So it's spelled L'Hospital, and I pronounced it L'Hospital for about a year before I learned it was L'Hopital. So don't make the same mistake. The idea behind L'Hopital's rule is if you have a ratio of two functions and you're taking a limit, and both the numerator and the denominator either go to 0 or infinity, plus or minus infinity, then you're able to, that should be a g, you're able to find the derivative, the limit, instead by taking the limit of f prime of x over g prime of x. So there's an important caveat, which is the numerator and the denominator absolutely must both go to either 0 or infinity. Here's an example of what happens if they don't. So consider the function 3/4, limit as x goes to 1. No, not right now. So then we can take the derivative of the numerator, the denominator, and we get 3 prime over 4 prime. But that just gives you 0 over 0, okay? So that makes no sense because 0 over 0, it's not even defined. And if we're taking limit as x goes to 1 of 3/4, that's clearly a constant function. So the limit should just, again, be the function itself. Okay, so does this make sense to everyone? Great. So let's do some examples. I actually left something off of my worksheet, which is these things should be limit as x goes to should be 0. I think it should be 0, and this should be limit as x right arrow. Do I want 0 or infinity? Let's say infinity. Okay, so in your breakout rooms, I want you to look at problem 4 on my worksheet, and I want you to try A, B, and C. And these, I warn you in advance, these are all fairly tricky problems, okay? But I think if you can do these problems, you can basically do any L'Hopital's problem, because these involve some methods that you won't see generally, but these combined with normal methods are basically everything there is to L'Hopital's rule. All right, so everyone's back. These questions are a little special because they're not questions that take a lot of time. They just need the right idea. So let's go over them. The first problem, I think people told me you had it on your homework. The idea is let's take the derivative, or let's take the limit as x goes to infinity of x to the n over e to the x. So we check, do both the numerator and denominator go to infinity? Yep. So then we can take a derivative and we get x to the n minus 1 over e to the x. And we can just take the limit of this. Now, do top and bottom both go to infinity? Yep. So let's take the derivative again. Then we get n times n minus 1, x to the n minus 2 over e to the x. So then we just keep doing this and keep doing this until we get n factorial over e to the x when x goes to infinity.
Oh, I think your screen is frozen. Like, you know.
Oh, really?
Yeah, we just see like the thing.
You guys should have said something sooner. Really? Yeah, so it is. Okay, let me start over. All right, so we're taking the derivative of this. We check that both, or the limit. We check both go to infinity. They do. So then we can take the derivative. And they still go to infinity, so we can take the derivative again. Okay, and then we can clearly just continue this process until we get, and that just gives you 0. Okay, so that tells you that for any power of x, e still grows more quickly. Yeah? Okay, let's do the second one. So these ones are the ones where you just have to have the right idea. So lim x goes to 0, x ln x is equal to lim x goes to 0 of ln x divided by 1 over x. Now we check ln x as x goes to 0 clearly goes to, I think, minus infinity. And in the denominator, we have 1 over x as x goes to 0, so that clearly goes to infinity, so you can apply L'Hopital's rule. So then you get lim x goes to 0, not infinity, of 1 over x over minus 1 over x squared, where we're just taking derivatives. And that gives you minus x as, sorry about the handwriting, and that gives you 0. So you get 0. And now let's do the last one. Do we expect this one to go to 0 too? So for the third one, I don't really know how you would take this limit, but did I say infinity? Yeah, but I do know how to take the limit right? So then this limit is going to be ln x divided by x. And so this gives you 1 over x and 1. And then the limit as x goes to infinity, that just gives you 0, right? So then what you can do is you can plug in, so we just found, call this limit L. So this is L. So we just found ln of L, but that means that we just have to raise L to the E, because, so basically, like, we just found ln of what we wanted, and so now we want to get what we wanted back. So this is, sorry, this is ln of L, and so then we can just do E to the ln L, and that gives you back L, but that's just E to the 0, and that gives you 1. Okay? So does this make sense, or are people baffled? Okay. So that's all I have for today. If you're confused or something, I don't have to be anywhere immediately, so just stick around for a few minutes and ask if you're having trouble.